This lesson is find the characteristic polynomial and the eigenvalue of the matrix. All it's asking is just find the eigenvalue. That's all it's asking. Okay, so here we have a matrix 2 by 2. Now we're going to take this matrix, subtract lambda to the identities. And if you remember, identities is just 1 0 1 0. That's it. Since this is a 2 by 2, I have 1 0 0 1 lambda times identity. So I just get lambda 0 0 lambda. After that, subtract across. So 5 subtract lambda, 3 subtract 0, 3 subtract 0, 5 subtract lambda. Next, we need to find the determinant of this matrix right here, the A minus lambda I. So find the determinant of this matrix. And if you remember, this is a 2 by 2. So A times D, which is here, minus B times C, which is here. After that, do more multiplications, add, subtract, simplify, and down to the polynomial that they're asking us. So characteristic of polynomial, which is this right here. So 5 times 5 is 25. 5 times lambda is this 5 lambda, but it's negative. Negative lambda times 5 is this negative lambda. And then negative lambda times negative lambda is positive lambda squared. 3 times 3 gives me 9. Don't forget the minus. After that, combine like terms. So I have lambda squared. This gives me negative 10 lambda. 25 subtract 9 gives me 16. Rewrite it in higher power down to the lowest power. So lambda squared minus 10 lambda plus 16. So rewrite it into higher order power down to the lowest power. Okay. After that, factor out, and this is factorable, so it becomes lambda minus 8, lambda minus 2. Solve for lambda, so lambda is 8 and 2. So they're asking us characteristic polynomial, which is this right here, eigenvalue, which is this right here. So one more time, this right here is the characteristic polynomial. This is our lambda. So the objective of this lesson is to find the eigenvalue, okay, which is your lambda. Next, same thing, a 2 by 2. So here I have the matrix, multiply by the lambda, and then subtract it, okay? So take lambda times I, which is this. After that, subtract, okay? So A minus lambda times I. Again, lambda times I is this, which is our identities, okay? Lambda times identity, and then A, subtract that. So 3 subtract lambda is here, negative subtract 0, negative 2 subtract 0, which is this, 2 subtract 0, which 1 subtract 0, which is this one, and then negative 1 subtract lambda is this right here. After that, find the determinant of it. So A times D, which is this, minus B times C, which is this here. So 3 times negative 3, 3 times negative 1 is negative 3. 3 times negative lambda is this right here. Negative lambda times negative 1 is positive lambda. Negative lambda times negative lambda gives me lambda squared, positive lambda squared. This right here gives me negative 2, but I have another negative to become positive 2. Now rewrite it in descending order from highest power down. So lambda squared minus 3 lambda plus 1 lambda, so negative 2 lambda, negative 3 plus 2 gives me negative 1. However, this is not factorable, so we need to use quadratic formula. Again, this is not factorable, so we need to use quadratic formula. So if you remember quadratic formula, minus b plus or minus square root b squared minus 4ac all over 2a. This is your a, this is your b, this is your c. plug it in. So there it is, I have here. Now just simplify. So this gives me positive 2, positive 4, and then negative 4, and then another negative 1 gives me positive 4. So 4 plus 4 gives me this 8. Square root 8 is 2 square root 2. Factor and reduce. Factor and reduce. The 2 go away. So I just have 1 plus or minus square root 2. So that is our value, our eigenvalue, which is 1 minus square root 2 and 1 plus square root 2. Again, this right here is called the characteristic polynomial. This right here is our eigenvalue. One more time. The first example is factorable. Okay. However, if it's not factorable, make sure you use quadratic formula. Okay, and this is a 2 by 2, so it's just lambda square. Okay, again, this is our characteristic polynomial. This is our eigenvalue that we are going to find, that we are looking for. Okay, one more time. This example is factorable. Okay, and this is a square. Okay, this is a quadratic, and it is factorable, so we should be okay with that. This is also a quadratic, but it is not factorable, so we have to use quadratic formula. One more time. This is our characteristic polynomial. This is the eigenvalue that we are looking for.